My name is Ryan Hallback, and I am a Principal Intelligence Analyst here at the Vertex Project, and I'm joined here with my teammate, Mary Beth Lee. And today we're going to talk to you about workflow automation and demonstrate how analysts can use Synapse to automate analysis tasks and help analyst teams operate at scale. We're going to start by first giving you a quick background on Synapse and explain to you why we developed this system. Talk about our analysis workflow and some of the pain points associated with it at times. Go over our solution to those pain points, which is automation. Go over some use cases for automation, and then end with a case study to demonstrate how Synapse automation can be used within your organization and across teams from beginning to end to help you set up some common analysis tasks. But first, Synapse. So at Vertex, we are a team of analysts, a company of analysts and developers, and we wanted to create a system that would allow us to perform every stage of the intelligence lifecycle in the same place. So in the past, when we needed to do analysis, we would have to do various aspects using different systems. So if we wanted to plan, we had to go to one system, do data collection and processing, we would do that in another system. And that process just became inefficient and tedious. What we wanted to be able to do was, collaborate across teams, represent data from any domain, not just the threat intelligence space, and then interact with that data easily in a way that allowed us to ask questions that we wanted to. So capture our analysis and assessments in the same place. So we created Synapse, which is effectively a system that combines a hypergraph technology with a data and analytical model. And then we added a custom query language called Storm. And then we added on services to facilitate things like data ingestion and enrichment and analysis, and also automation, which is what we're going to cover today. So at Vertex, we like to say that Synapse uses data, platforms, and teams to allow us to collaborate and perform interdisciplinary analysis. One of the challenges that we tried to address, when we created Synapse was analyst scalability. So our team was doing a great job of producing intelligence. So our customers wanted more and they wanted it faster. So we wanted a way to increase analyst throughput and production. So to address this, we integrated a set of tools that would facilitate workflow automation. So what you see here in this diagram are some of the phases that's commonly associated with our analysis workflow. And then within each phase, so within the collection phase or enrichment phase, then you have a set of tasks that's commonly associated with that phase. How tasks are performed, it would vary. And for you out there, it may vary, by your organization, because it's going to depend on the amount of data that you have and the tools that you have internally and what the tech looks like internally as well. But what maybe some of you can identify with is just how tedious this process can be and how complex it may be. What you may notice is that in the middle, that core analysis phase is not linear, it's cyclical. So what this means is that it's time consuming. And if you notice, the diagram indicates certain tasks that are performed normally manually, right? Those manual actions are highlighted in white. And if we did have some automated actions, they would be indicated by green. In a normal system, we wouldn't have any automated tasks for the most part. Everything that we did from data collection to clustering and analysis, even performing assessments, so tagging indicators, all of this would be done manually. So whenever we had an inbound research request, that request would take several hours or even days, depending upon the task at hand. So when we took a look at the automation landscape, what we found were that there was automation that existed in threat detection platforms and in analysis platforms. But the problem was it was just resolved to maybe the beginning part of the analysis workflow and at the end. So for an example, we would have, automation that was focused on data collection and enrichment, or automation that was focused on information sharing. So it wanted to focus on leveraging finished intelligence or context that had been identified by analysts, and it wanted to send that context out to defenders to help them prioritize threats or respond to threats rapidly. But the question we had was, what about everything else in between? What about the core analysis phase? What automation was put in place to help us accelerate our analysis? And we just couldn't find it. And if we found it, it wasn't done well. So essentially, automation for analysis was lacking. Why was this a problem for us? Well, because we had a lot of data coming in that we needed to analyze, and it was impossible to process that data manually and analyze it. And it was really impossible when we had a high production demand and we needed a quick turnaround time for things like IR investigations that we were supporting. Analysis can be hard, but it can also be complex when you're performing things manually. And because of this, sometimes we would notice that errors were being introduced into our analysis. Why? Because we're human and mistakes happen. There is also a shortage of analysts, in our team and just really within the analysis community in general. So as attackers are getting more sophisticated and advanced, that means that the data that we need to analyze related to those attacks that require more advanced methodologies as well. And even myself as a trained analyst, right? I've been doing analysis for several years. Over time, I have to continuously evolve my skills to keep pace with the data that I'm analyzing. So we decided to introduce automation. What does automation look like in Synapse? In Synapse, we define automation as analyst-defined and codified workflows created in the system to help us perform basic or advanced tasks that do not require human review. So as an analyst, there are usually a common set of tasks that we often perform when we want to analyze a certain type of data. So if I want to investigate a domain or do some malware clustering, there's a natural progression usually associated with that type of analysis. So whether consciously or subconsciously, I have a set of predefined workflows that I use to analyze that data. So if I want to analyze a domain, for an example, maybe I'm going to pull in some whois data or some active or passive DNS data, maybe some sandbox execution data, and then reason over it and pivot through the graph to identify certain connections. The same way with analyzing malware. I'm going to pull in some static or dynamic malware execution data, and then maybe I want to look at that file in the graph and pivot to DNSA records or maybe an IP address. And then look for other DNS resolutions to see, hey, can I identify any other malware that's also been communicating with these domains? So the question we had is, if these workflows are formulaic, right, if they follow a specific methodology, so if my analysis can be codified, then why not automate it? And why not leverage, my analysis that I can codify and use, I guess, analysis that requires human interaction? Why not leave that to be done by me and have everything else be done by the system? So at Vertex, we like to say that whenever we can use automation, that superpowers the analyst because it saves us time, it ensures consistency and rigor across our analysis tasks, and it helps scale the analyst when we're low on resources. What I want to point out is that automation in no way replaces the analyst, it augments us. So analysts, we feel like will always be needed because there will be certain tasks that require human review. When you're looking at automation in Synapse, it's actually the analyst who creates the automation. So we decide where we want help and also where we want to insert ourselves in the process. Synapse facilitates two types of automation. We have time-based and event-based. And what you use depends on when you want a particular event to kick off in the graph and what you want that automation to look like. So first we have cron. This is time-based automation. This is where actions occur at a specific time, and it's not time sensitive. On the other hand, we also use triggers. These are event-based automation events where actions occur immediately when a system event occurs in the graph. And these are usually time sensitive. So some of the events that can trigger certain automation to occur would be when a node is added or deleted from the graph, whenever the property of a node is changed or modified in any way, or whenever a tags are which we apply to nodes to indicate some type of assessment. So whenever a tag is added or removed from a node. So whenever a particular time, is encountered or a system event is encountered in the graph, what you can have is the system execute a storm query on your behalf. And that storm query is any type of analysis or any operation that you would normally perform as a part of your workflow as an analyst. So if you would normally pivot from a file to a DNS request to identify a C2 node or a piece of infrastructure, you can automate that. Or if you would normally enrich an IP address using Shodan or our virus total service, you can automate that as well. as well. The advantage that we have with automation within Synapse is that it is analyst defined and created. It's not developer driven. So what this means is that there are no DevOps cycles required to implement automation. So that means no system downtime. You can test and deploy your automation within a live environment. And then once you deploy it, it's global. That means that every analyst across the team can take advantage of it immediately, as long as they have the proper permissions to do so. Here are some examples of actual, automation that we have in our production system. So looking at Cron, for an example, we have a daily RSS ingest that runs, for an example, daily at 8 o'clock to pull in new RSS data from RSS feeds that we've identified. We also have triggers that run within our environment. So whenever we have a new IP address that gets added to our system, we have a set of filters to be put in place to make sure that, hey, if this is a unicast address, let's go ahead and call out to Maxmind to enrich that IP address and pull in some geolocation data. We also have a Yara trigger that runs, and that Yara trigger runs, for an example, when we're doing some of our OSINT codification. So for an example, if we have a file bytes node that gets tagged with a rep tag, in our case, internally, that means a report tag. So if, for an example, Kaspersky reports on a file bytes node to indicate that it's malicious, we want to go ahead and run that against our Yara service to determine, can we classify this malware family with maybe something that we've created internally, so an internal malware family. And if we can't, we want to know if we have a detection gap internally so that we can shore up our defenses. The one thing that I want to point out about the way automation is set up within Synapse is that automation is modular, which helps make it more manageable and inspectable, right? If you need to do some troubleshooting. Another benefit to it being modular is that it can occur as a standalone, so as an atomic event, or it can be chained together so that you can cause a sequence of events to occur, so that the execution of one piece of automation can then maybe be the start of another piece of automation. This allows you to either automate discrete tasks, right? So a single thing that you need to perform as an analyst, or an entire workflow if you would like. When can you leverage automation within Synapse? Essentially, whenever you would like to. So if you identify the opportunity to automate any part of your analysis workflow or lifecycle, you can. You can also automate anything that you want to regarding system maintenance, maybe, or even housekeeping. So some automation examples include ingesting tasking from external systems, like a Jira ticketing system, enriching data that may be related to one of your current research tasks, performing hunting and detection using services like Yara or hybrid analysis. You can even analyze data using automation. So if you want to cluster data in the graph by pivoting through data and identifying key relationships, you can do that as well. So to demonstrate how automation is used in Synapse, we're going to walk you through a case study. We're going to show you how you can use automation to accelerate interdisciplinary analysis support for MDR services. Now, this particular use case is related to MDR services. However, what I want to point out is that automation can be applied to any set of research tasks by any team, whether big or small. So if you are a small threat intelligence shop and you want to research some IOCs that you identified in OSINT, you can automate those tasks. Or if you are a SOC analyst and you want to investigate a domain for your security operations team, you can do that as well. So for this case study, what we have is a situation where a managed defense and response customer for a security services firm, they checked their Synapse-powered customer portal for a suspicious domain, something that they noticed within their environment. When they check for this domain in their portal, nothing is found. So since it's not found in their portal, that means that no context must exist for this domain within Synapse. So because of this, the customer then submits a research request in the portal, which then automatically results in the creation of a Jira ticket. Once this Jira ticket is created, an analyst is alerted of this request, and then they initiate an investigation in Synapse. And once this investigation kicks off, automation in Synapse is triggered. So what does triggering automation look like in Synapse? So if you recall on slide 5, when we talked about our analysis workflow, every action was manual, right? Every bullet was white. And we talked about how time consuming this could be and how tedious it was, and also how it was error prone. Now, if you juxtapose slide 5 with this one, slide 5, you saw a workflow dominated by manual analyst actions. Now, if you look at this slide, what you have now are tasks that have been replaced with automation to help augment analysts where they see fit. Now what you have is more of a smart analysis cycle because you have automated actions that are interspersed with manual actions. Now analysts can operate at scale because now they can use Synapse to execute tasks on their behalf and then leave other tasks that they want to do manually, to look at a later time. This saves you time. This also increases productivity, and it ensures that analysis processes are consistent across your team. So now by implementing automation, within a matter of minutes, we're able to determine that this domain is in fact malicious. We're able to determine that it's associated with the Coney malware family. We were able to even identify associated IOCs, so like domains and URLs and emails, and get additional context like DNS records. So the question you may be asking is, how do we go from having zero context about the suspicious domain in the MDR customer portal and in Synapse to having this context-rich indicator page? We did this by primarily using automation, which is indicated here in green, with a few manual analyst actions, which are shown here in white. So what this flowchart shows you is literally every action that occurred to research and try to contextualize this domain. Each block that you see represents an action, whether that action is a cron job or a trigger or a manual analyst action. So if you start here at the top left, what you start with is a single piece of automation, in this case, specifically a cron job. This cron job was created to pull in a JIRA ticket and tag it with an MDR tag. And the creation of that ticket and the application of that tag to that ticket, it triggered a chain of events. What it triggered and caused was for the tag description to be set so that other analysts who encountered this new tag in the graph, they knew how to interpret the data that was tagged with this tag. It also caused the reported domain that was identified in that JIRA ticket to be scraped out and added to the system and tagged as well. This then resulted in another piece of automation kicking off. It caused that domain that was in question, that suspicious domain, to be enriched. So data related to that domain that we found in another customer's appliance, a phishing email, was then added to Synapse. And this then triggered more events. So effectively, what you ended up with was several discrete pieces of automation that occurred successfully. This allowed for a large research task to be performed in a matter of minutes. So in this case study that Mary Beth is going to walk you through, what you will literally see is how we automated nearly 20 research tasks, right, to research this domain. We researched pulling in the JIRA ticket that the customer created. We automated enriching the domain. We automated clustering based on related binaries and even the spear phishing email that we came across. We even were able to automate setting natural breakpoints in our analysis where we wanted analysts to come in and manually review things by adding int review tags to indicators that we came across. So to see what this looks like under the hood, I am now going to pass it to Mary Beth so that she can show you the cron jobs and the triggers that made up this analysis workflow.
Okay. Okay, hopefully you can all see my screen now. So what we're going to do is, as Ryan had mentioned, we were able to use our giant automation to figure out that this domain is actually a C2 for Coney malware. So what we're going to do is I'm going to run the automation, which will not take very long, and then we're going to go and walk through it to see what happened and what we found. So the first thing that I want to show you is that we're starting with a blank slate. This is the domain that we're asked to research. It doesn't even exist in our Cortex yet, so nothing is there. What we're going to do is that the first thing that we're going to use is a cron job, which is going to run It's set to run every hour, and it's going to pull in Jira tickets that are filed under that MDR project. And you can see the cron job over here. This is the one that we're actually going to use. And it's going to execute a macro on this side. And you can see that the macro is named create Jira ticket. Macros are just like containers for Storm code, and it can be used both by cron and by triggers. Another piece of automation that we're going to use a lot after the cron job are called triggers. Triggers are basically event-based automation. So if something, you set it so that like when X happens, I want automation to do this. The triggers that we set and that we use, we name them all after the different parts of the research process that they're going to facilitate, just because it was a little bit of a way for us to organize ourselves. So we can use them to help from everything from the initial inquiry, where we want to create a Jira ticket, to collection, enrichment, assessment, and analysis. We can also go over here and we'll edit this one so you can see what it looks like. So this is a Jira ticket that is going to populate title and tag properties of the new VTX MDR tag. So whenever we have like a new research story that's under that VTX.MDR story tag, it will go and it will do some housekeeping for us and just like say, this is the title of that tag and this is the documentation for it, so that people know what this tag means. They go and look for it later. And we'll go over to the Storm editor. This is where the macros live. Again, macros are just the containers for Storm code. So this is the one create Jira ticket that our cron job is going to call. And this is just the code that macro contains. So now that we've seen where those live, we're going to go ahead and we're going to run, I'm actually going to run that cron job query manually, because if we waited for it to go off at 2 p.m., this would be a really long, boring webinar. So I'm going to run it manually, and it's going to kick off pretty much all of our other triggers and all of our automation that is going to happen, except for one or two things, which I'll point out as we go. So let's go ahead and run that. And so what this is doing is that it's going to scrape in that Jira ticket, and it's going to create a project ticket node. It's going to apply a tag, the VTX MDR 2021-872 tag to it, which is our particular story tag that we're using just as a way to kind of keep all of our findings organized. And that's going to cause kind of this cascade of other triggers that we had set up to go off, everything that's collecting data from, scraping in the domain that we have here that we want to research, to enriching it, to making assessments, tagging things. There's a couple things that I had set up in our workspace preferences that are just to help me kind of identify what I want to look at and what's probably going to be the most interest, or things, or flag things that are going to be something that an analyst should verify. If you notice, this ticket that came in is colored. I can't tell you what this color is, but I know I said it. It's not pink. Let's say it's periwinkle. Everything that has a VTX.MDR tag is going to have this periwinkle color. Everything that has a int review that's tagged internal review for an analyst to look at is going to come in with a yellow tag, or it's going to look yellow. Everything that had an assessment on it that was placed like an assessment as this is malicious is going to come in with an orange tag, an orange CNO-mal tag. So now that we've run this, let's see, we're going to lift all of the nodes that were created in the Cortex in the last 3 minutes, just to see how much actually came in with that automation that we ran. So it looks like 1,186 nodes were created when we ran this. So everything that we're going to be working with, everything, all of the enrichment things just came in with that one command that we had ran. So let's go look at our Jira ticket. We'll go back to this ticket for 1 second. So this is our Jira ticket. This is the name of it, and this is the indicator that we were asked to look at in the body. And again, it's this periwinkle color because it is tagged with our VTX MDR story tag. And we'll go pivot on that. And we can see this is our domain that we were asked to research. It's yellow because it has that analyst review, internal review tag added to it. And we can go pivot on this and see what our enrichment brought in. So one of the first things that I might notice is that we have a INET DNS request, that came in. So it shows that this file actually communicated with the domain that we're looking at. So we might want to go pivot on that and see what we have there. So here's that file. We can see it's an executable. We can see the compile date. And if we go over to the details on the side, we can see that has a couple tags here. One of them is in orange. It's that cnomal.coney. So an assessment was made that said that this file is malicious. It's actually a sample of Coney malware. That's what the tag is telling us. We have our MDR, our VTX MDR tag saying this is part of your research. And then it has this internal review.yara. So this internal review.yara tag is something that we set in our animation that every time you make an assessment, we want you to flag it for analyst review. In this case, our automation, when it enriched our domain and ingested this file, it took the file and it ran it against our Yara grid service. And so this hit on a rule that was designed to detect Coney malware. And so that's where it got the cnomal.coney. And then the automation applied that tag, that internal review.yara, so that an analyst would go and verify this. Is this, how much do you trust this rule? Is this actually a sample of Coney malware? So if we wanted to, we could go and pivot there. And so we're looking at that file right now, and we can go use scroll to form and down to the IT app Yara match. So we can actually look at that rule that it matched against. Here's our rule. Let's pivot there to see it. So this is our rule. If we go over on the side, we can see the name, it's Coney. We can see the text. We can also go and say full text if we want to take a look at what this rule is. So this is the rule that it hit on. It's one that we wrote ourselves, so we probably trust it. So let's say that I decide that, yeah, I trust that rule. I trust that this file is something that that did match here. So I might want to go and get rid of this internal review because I did just review it. It looks fine to me. I think we're good to go. It's Coney. So I might remove that there. And I might go back and look at this file again and see if there's anything else that might be of interest to me here. So we'll go to the scroll to form. One of the things that I might look at is this file subfile. Say like, did this drop something? Or in this case, actually, it was dropped by something. Here's the file that dropped it. Here's the file that we're currently looking at. And all this data that I'm looking at is what was brought in by our enrichment query that we ran. So let's go pivot on that and see. So this is the file that dropped this guy that we were just looking at. So the one in yellow is also tagged with internal review.yara. And we can see on the side here that it had actually ran against that same Coney Yara rule. So since I just reviewed that, or just reviewed that rule and I trust it, we could remove that internal review tag. I might want to take a little bit more of a look at this file just in case there's anything interesting. And don't really want to look at all the hashes, so I can just go. And one of the things that might be cool to look at is this inet email message.attachment. You can see if this file was delivered as an attachment. This is something else that has an internal review that was flagged for me. So it looks like this was an email that delivered our file, or delivered the file that dropped the one that we were looking at previously. It's from the, what is this? The Antiquities Coalition.org, which I've never heard of. Can look at the body here. We can hover, but I usually just go to show full text because it's a little easier to read. And so here's the email, the body of the email, and it looks like it's about Burma, UNESCO World Heritage Site status. The attached photo picture is one of several Myanmar temples designated as a World Heritage Site. This must be stopped. Let us hear from you. There's this, I've never seen think tank.antiquitiescoalition.org. So let's say that I dug into this and I decided that, this looks like a phishing email to me, especially since we know that the sample that delivered is Coney. One of the things that I could do that I could have automation help me with is that I could go ahead and I could tag it with, let's say, sudo fish.email. When I tag it, it's going to set off a trigger that is going to go ahead and kind of push those tags down through all the other related indicators from this message. Like it's going to tag the recipient email, the sender email, and it's going to tag the payload. And so I'm going to go ahead and tag this and set off that trigger. And it also removed that internal review. Since let's go pivot here and see what happened. So this is the target. This is the email that was sent to, and we can see that automation, the trigger went ahead and pushed that ttp.fish.tgt tag. And this should be Antiquities Coalition, the sender. It was tagged there. And we can see the attachment. And this is the file that was attached, and it got tagged with the payload. So that was a little bit of automation where we were able to just kind of do some tag and cleanup. And I only had to tag the email, and everything else kind of got tagged for me from there. So now that we know that our domain looks like it was used as a C2, it was communicating with a sample of Coney malware that was dropped by another Coney dropper that was delivered by this spear phishing email. We might go ahead and tag this with cnomal.coney. And I'll go ahead and get rid of that internal review because we did just review it. And we could set up some more automation depending on what we're using Synapse for or what we're connected with. So that if we wanted to, that every time that we apply a tag like this, maybe it goes and it pushes out that information to whether it's a SOAR or it's some sort of detection product, maybe even Jira if we're working with another team that just lives in Jira still, and we want to share our findings with them, that's something that we can also automate. Another thing is that like a lot of our research doesn't just like end with when we have our finding. A lot of things kind of tend to cycle through and continue from there. So in this case, one of the things I wanted to show you is that we found that this domain was actually showed up in a string that was with a code function. And if we pivot there and we go and we look at that function to see what other strings are in there, here are the other strings. Here's our domain. We see that there's a file name, and it also looks like there's another domain here. In this case, this might be a place where we want to go ahead and add, let's say an analyst review tag. We want to tag that domain with int review because this one domain was a Coney malware C2. Maybe this other domain is also a Coney malware C2, or maybe it's malicious. Maybe it's not related. Either way, it might be worth checking out. We could easily do a trigger so that when we apply this tag, it goes and it creates a Jira ticket for us. And so somebody else, whether it's me tomorrow or Rain, later today, someone else knows to go and take a look at that domain. And that's an easy way to kind of like keep track of your research and also create tickets so that you can continue researching and not lose things in the graph or lose where you are in your process. So to just go over where we are, we were able to use automation to facilitate basically every part of our research process, everything from receiving the initial inquiry about that domain, getting it into our cortex, to enriching all of our data, to making assessments, going and tagging things, and then analyzing them. In our case, we wrote our automation so that we could go and check some of the assessments because we wanted to make sure that if we were tagging something as mal.coney, that it was actually Coney. We were using that int review tag so that we could go and check on these things and verify them all. That's not something that you would need to do. Rain and I wrote all of the automation that we used for this, and we wrote it as we wanted it to work. If your team is comfortable having your automation make assessments for you, you don't even have to have that like analyst check built in. It's really whatever works for you, whatever works for your comfort level and your research process. These are all the automation is analyst defined, analyst constructed. So it's flexible and you can use it to help with whatever your research process is. So that's it for today. Thank you for joining us, and I hope that was helpful.